Okay, Phil, Amy, are we ready to get started?
Certainly are.
Yes.
We have about 18 people or so. I'm sure others will. So good morning, everybody. I want to thank you for taking the time to join Google and Datametica this morning on this for this event. What we're going to do this morning is we're going to talk a lot about some of the things that Google is doing in retail, particularly Google Cloud is doing in retail, to facilitate the retail operations of the retail business, and ultimately drive stronger outcomes in retail. And as everyone's aware, this has been a particularly stressful time for the retail industry in general, with pandemic and other factors coming into play. There's really a lot that Google and Datametica can do to help here. So my name is David Solomon. I'm a lead cloud architect. I'm actually based in the Mid-Atlantic area near Philadelphia. And joining me this morning is Amy Eshelman, who's one of our retail leads at Google Cloud, and also Dr. Phil Shelley, founder of Datametica, who will be speaking a little bit later. And so we have a couple of things lined up this morning. Specifically, we're going to have Amy give us a little bit of overview on, what Google Cloud is doing in retail, and why you should think about Google as a retailer in partnering with us. Then we're going to talk to then Datametica is going to talk a little bit. So Datametica is a key partner for Google in the data and analytics space. And they're going to talk a little bit about some of their experiences in applying Google's technology to retail. And then finally, I'm going to join in at the end here and do a little bit of a walkthrough of some of the technology in sort of a day of the life, in terms of what retailers will specifically, what they can specifically do with the technology. And so one other thing I do want to mention is we have a few folks that are going to be monitoring the chat. So if you do have any questions during any of the presentations, feel free to put it in the chat. There's a button at the bottom right-hand corner of the meeting that looks like a little chat icon. Just click on that. It'll bring up the group chat. Just post your questions there. We have a couple of folks that will be monitoring that and answering any questions that you may have. So with that, what I'd like to do is turn it over to Amy to kick us off.
Great, thank you. It's nice to be here with all of you. As David said, I am part of our industry solutions group. I'm the Americas lead. I'm actually a retailer by background. I come from a lot of years in specialty retail, Williams-Sonoma Inc., most recently there at Pottery Barn, and then most recent is Sephora, where I was led our North America e-commerce and then moved on to our client experience. So it is great to be here with you and talk about how Google is helping retail. I wanted to start with some context, and I think that these numbers kind of point to give some oomph behind the trends that we've all felt. We have an extensive amount of customer research that we do, as well as look at our own search trends. And what we see is a definite shift to how we discover and shop online versus in stores. And this comparison is basically 2017, 2018 to 2020, 2021. And you can see some pretty dramatic shifts. So, back in the day of 2017, 2018, 48% of people said that they discovered products in the store. It was the main reason they shopped in the store. Turn that completely on its ear to now, and now you're seeing 70% of the customers we surveyed say that they bought from brands discovered on YouTube. That's quite a shift in how people discover product. And then how comfortable they are with buying online and experiencing things online. We go from 72% preferring in-store shopping to 63% wanting to try products on from the comfort of their own home. So being more comfortable with that in-home experience. And then finally, buying online, half of the people in 2017, 2018 that we surveyed said they would just certainly never buy products online. Move that now to 74% buying those exact same products online. As someone who comes from the beauty industry, definitely felt this shift. If we go into our search trends on the next page, you'll see, David, I don't know if there's a delay or if you wouldn't mind going to the next page. There we go. Sometimes there's a little bit of a delay. So what we're seeing in search trends is two trends I wanted to highlight. This first trend is kind of where our mindset is right now compared to where it was at the beginning of the pandemic. And you saw at the beginning of the pandemic, people moving towards branded terms, something that they knew, that they could trust. You know, this high anxiety time period, being more comfortable with brand names they knew. Now shift that to where we are now, and you can see this, you know, fatigue, pandemic fatigue sit in, as well as kind of the you know, gradual opening up, and you see more generic searches coming into play. People are open to discovery, open to trying new things. If you go to the next page, we'll see kind of some other behavioral shifts, and I think that both of these speak to value, but the mindset of value. So at the beginning of the pandemic, we saw a huge increase in the search for cheap. So things that had the term cheap in it. Because economic uncertainty, all sorts of anxiety, people wanted to make sure that they were getting the most for their money. Now shift that to where we are right now, and you see the best term come out more. And I think that still speaks to value. Customers are still looking for the best use of their money, but they're doing so in less of a shock behavior. They're more kind of accustomed to where we are, and they're open to exploring things that are just the best value for their money. If you go to the next slide, I think in all of this, you know, we realized in the pandemic that in order to react to that, as retailers, we needed to move quickly. And that's really no different than retail has always been and will continue to be. We know that it's a race to change, because shifting customer expectations create opportunities, and they can create the emergence of new competitors. And just a few examples of competitors here, or really innovative companies on the left-hand side of the page, as well as the types of experiences that we've seen really drive some true innovation on the right-hand side of the page. Within this environment, Google Cloud aims to help retailers be able to move quickly and react quickly and to be innovative. And if we go to the next page, there are a few key things that we hope that really help retailers. The first is that we have aligned around retail industry solutions. We have 9 industry groups, retail being one of the largest and most quickly growing. And it's, you know, of course, an industry that retail, or that Google has had a significant amount of history with since the beginning of Google. We've hired in industry experts like myself that come from retail, but it's not just in my position. We're hiring engineers that have retail experience. We're hiring project managers that have retail experience. We're really bringing in that expertise to help develop the solutions that we know will help the industry of retail. You also have Google's leading AI and ML expertise, something that we have been known for, and we are really proud of applying that to the retail industry. And one of the things that makes cloud special is it can truly bring the best of Google. So if you think about integrating experiences across all of Google's surfaces and product areas, cloud can really serve as that glue and as that conduit into those other areas. And then finally, we're built to scale. We have 9 products with over 1 billion users, and that is really the strength of our cloud products, that they are built to scale. With that, let's go to the next page, and I'll talk a little bit more about retail. Well, first, we're very proud that last year we were named the #1 cloud provider for retail. We have 7 of the 10 largest retailers within our ranks, or work with those within our customer ranks, and we are very proud of the relationships that we form with them. On the next page, I'll talk a little bit about where we are making our investments in retail. So we really look at 3 key areas that we have positioned to help the retail industry. The first is capturing digital and omni-channel revenue growth. So this is not only e-commerce, migration, modernization, digital experiences, but we are also developing digital experiences that are very, I think, unique to Google. One of them is our product discovery suite. So Google has been known for product discovery, and we are now applying that to the retail industry with our Google Retail Search solution. In this second pillar, becoming a customer-centric, data-driven retailer, it's really not only just kind of the transformation that you can do with data and housing and storing and using that data in a different way, but we're also here applying our AI and ML expertise to specific retail data. One of the great examples of that is our demand forecasting solution, which is in our Vertex AI platform, that really does use the best of Google's algorithms and your own data to develop a more accurate forecast, even when that product is a cold start product, has no history. And this final pillar is driving operational improvement. So not only reducing operational costs by moving IT infrastructure to the cloud, but our contact center AI solution is a great example of applying AI and ML in a unique way to help reduce costs of customer support, whether by voice or by chat, as well as improve the customer experience. I'm going to go through a few examples of clients that we work with, as well as go a little bit deeper into each of these solutions or each of these pillars. So the first, as I mentioned, was capturing digital and omni-channel revenue growth. I won't dive too deep into this because we just talked about it on the prior page, but some great examples here: e-commerce migration, modernization, and then our product discovery suite. You can see there it has visual search, recommendations AI, which is our recommendation engine, and retail search. I'm going to talk a little bit more about that middle column. If you go to the next example, Ulta is an example where they've developed on Google's platform some really unique customer experiences. This example is an AR beauty experience, which is it came in incredibly handy during the pandemic when you can't visit the store, but you still want to try on beauty products. So the ability to just point your phone at your face and try on a new product. What I think makes this really unique is that Ulta was able to use the data from over their 30 million loyal customers in their loyalty program and create a recommendation engine that helped drive conversion and sales on a fun experience, but a fun experience that drove revenue. The next example we have is another example from beauty, and this one's near and dear to my heart since this is where I came from. So Sephora is an example of a recommendations engine as well. They use Google's recommendations AI that helps drive better, more personalized recommendations across a variety of locations in their site and in their digital advertising. So this recommendation engine that is powered by Google drove some fairly substantial improvements in the click-through rate, as well as overall conversion on the homepage, and was syndicated across the site, as well as in emails, and even within display ads. This recommendation engine was able to power better product recommendations within a display ad that helps drive more efficiency in those as well. So now we're going to move on to the second pillar around becoming a data-driven, customer-centric retailer. And it's tough to separate out these strategic pillars, as you'll notice, because data really is the foundation for those experiences we just talked about. But within here, this pillar, we talk about our data warehouse modernization, but the other parts of this pillar are really unique uses of data. So we have a customer data platform solution that we deliver with partners, or you can build on top of our platform. And then we have abilities to share insights across the organization with our retail analytics product with Looker, as well as ingesting the data in a time-based way that helps drive new AI and ML use cases with our retail common services. And then finally, activating that across the organization with products or solutions like our demand forecasting solution, which I just talked about, as well as email personalization, which we deliver with a partner. On the next page, I have a few examples of this. Oh, there we go. Thank you. So Best Buy is an example of a company that is working with us on data. This is from a press release that was released last year. We are very excited to work with Best Buy. Best Buy has always been a leader, I believe, in personalization. And so the ability to take their data sources, break down the silos, house that within a Google solution is unlocking the ability to drive more AI and ML use cases. You go to the next slide, David. We'll go into our third pillar, which is driving operational improvement. So some really interesting examples here: intelligent customer support with business messages and that contact center AI solution that I talked about earlier. And that's one of the case studies I think we'll discuss. And then fast and efficient operations with solutions like SAP on GCP, or Anthos for retail, which allows you to have do better management of a multi-cloud platform. And then finally, our workspace solution helps retailers with collaboration and more efficient operations. Let's go to some case studies. So Home Depot, this case study I think is very interesting. They moved their SAP data onto GCP, allowing them to have access to inventory information. With that information in Bigquery, they were able to drive some more sophisticated AI and ML use cases. And in this case, it was a shelf out situation. So imagine going to a home improvement store, and if you don't have all of the parts, the project's kind of ruined. You have to move on to the next store to get everything you need to complete the project. And those shelf outs can be a huge driver, not only of lost sales, but lost customer satisfaction or decreased customer satisfaction. They were able to run models on the data that help them predict when a product might be out of stock by the sales rate, by either time of day of the week, time of the year, etc. And that helps them drive a 2x more accuracy on that predictive algorithm. With that type of increase, it helps drive some top line sales, which even a small percentage improvement at Home Depot scale can drive significant amount of revenue. The next example we have is our contact center AI solution. This example is from Marks & Spencer, a UK retailer. Marks & Spencer routed all calls that came in through their stores, which is a fairly expensive but incredibly high quality source of customer service. But they were getting inundated and it was getting cost ineffective. What they did was automate those switchboards in 13 stores to help migrate the calls to a central call center and have those calls answered by our contact center AI solution. It helped dramatically reduce the amount of calls that went to the stores because you could answer the easy questions all in an automated way with incredibly high customer satisfaction. So a strong example, I think, of in retail, it's the holy grail of a lower cost solution with improved customer satisfaction. With that, I'm going to end here. I wanted to just mention that we work with a variety of retailers across all segments, as well as great partners like Datametica. And so we are very excited about our relationship with our clients. We're excited about what retail can do with the power of the cloud, and very excited to have such a strong network of partners. With that, I'm going to turn it back over to David.
Okay, thank you, Amy. And can everyone hear me now? I had some audio issues earlier.
Yes, David.
Oh, okay, great. So real quick, in case anyone didn't hear me earlier, if you have questions, feel free to post them in the chat. We have some folks monitoring the chat. And with that, I'm going to turn it over to Dr. Phil Shelley from Datametica.
Thank you, David. Little bit of background on me. I'm one of the founders of Datametica and the president. I have a retail background also. Before we started Datametica, in fact, all the founders of Datametica, we worked at Sears Holdings. I was the CTO at Sears Holdings, which was Sears, Land's End, and Kmart. Sears Canada, Sears Mexico. It was a large retail environment before, of course, it was all spun off. So I'm happy to be part of this and take you through it. So this is the Datametica view of how we really get retailers modernized to GCP, and we've done a lot of those over the years. So thank you, David. You keep going. A focus for Datametica is in three segments. One is platform modernization. We've talked about that. Usually that's where we get involved first. Retailer has significant legacy. It's been around a long time, so we had that ourselves as customers. Data warehousing, data pipelines all need to be modernized to take advantage of new data, especially new and real-time data. The next is what Amy's just been talking about. Data science and use cases on top of retail is a big area of focus for us. And then, of course, service delivery. How do you run this on a day-to-day basis is another important piece. So 3 verticals for us. On the bottom left, you see 3 tools. They're all bird name tools. I'm going to cover those in a minute. Those are the automation tools we've built over the years to accelerate and de-risk the migration to the cloud. And I'm going to talk about that a little bit. So keep going, David, please. Our mission is helping to get a business to the Google Cloud faster and cheaper and with less risk than ever previously possible through automation mostly and our expertise. And in retail, we see typically large amounts of data, of course. Teradata and Netezza and Hadoop and Oracle are very common in larger, but we also see SQL Server and Sybase DB2, mainframe, Greenplum, and many other things. So whatever it is, in terms of data analytics and data warehousing, we are very expert in moving that faster and cheaper and with less risk. And I'm going to explain a little bit how we do that. Keep going, David. We although we started with retail and we have a retail background, Datametica's tooling is agnostic largely to the vertical. Although retail is our foundation and we have a lot of experience, I just want to explain these techniques that I'm talking about today and tools are really agnostic to the retail vertical. These are just some of the examples in retail of the logos that you will recognize that we've helped to migrate to the cloud. Thank you, David. First of all, a little bit about the automation. So when we ourselves were customers and moved our own systems to GCP, that took a rather large team for a very long time to move Teradata, Hadoop, Exadata, some Vertica mainframe. All of that took years and well over 100 people dedicated for around 3 years, and that didn't even move all of it. So we knew that moving these large systems with that amount of effort and time is untenable. We have to find a way to automate these migrations. Datametica spent the last, we're in our 9th year now, building these automation tools. One around discovery and planning, understanding what's running, how it's connected from a lineage point of view, what the ETL pipelines are doing, what the consumers of data are doing, and build a migration plan, fixed bid, fixed time out of that. That's taken out a lot of the unknowns and the uncertainties in the early phase. The next is we have hundreds of thousands of objects that have to be migrated. Although the data model today can be moved without really many changes onto Bigquery. Bigquery is very tolerant today, for example, and that's the main target for us. Bigquery is very tolerant of legacy data models. But there are functional differences in code. People write, of course, code in different dialects that are suitable for the platform it's coming from. That has to be harmonized into an ANSI standard, Bigquery friendly SQLs, for example, stored procedures, BTEX on Teradata, wrapper scripts, ETL transformations, all have to be modernized. And this is where our Raven tool comes in to automate the modernization of code and the actual DDLs and data definitions. And then finally, how do you validate this code when we have hundreds of terabytes or petabytes of code? We want to make sure that we can run the new environment on Google Cloud in parallel for sustained periods of time, so we can validate the data and give people time to do change management, training, cutover. We don't want big bang overnight cutovers. We want long periods of time where both systems are running in production in parallel. Well, previously that's impossible to do at hundreds of terabytes or petabytes of data. You can't validate with traditional methods. So we use hash algorithms, blockchain hash algorithms in the back of Pelican to avoid moving the data over the network, but still validate data continuously, not just once, but continuously validate data at a row and cell level, and give us assurance we actually have something on GCP we can really cut over and trust. These three tools have taken out more than half of the time and cost of migrations. We're almost at 2/3 reduction now in time, and most of the risk, because now we can run in parallel. So thank you, David. And how they fit in, these birds tools fit into the journey, is there's a pre-migration phase where we want to understand what we have. How do we get started? Many people think that they have a very large, let's say a Teradata system, large Oracle system, it's impossible to move. Well, that's why this pre-migration phase exists. It is possible to move it, and this will show you exactly how to move it. The next is, how do we migrate it? Actually transforming the code, transforming the ETL, and then the reconciliation of the data. So this is where the tools fit in. There is also a use of our Eagle tool post-migration for optimization, optimizing query times, optimizing query cost. That's a growing area, although we still have an awful lot of legacies still to move to GCP. Thank you, David. So I'm not going to go into too much detail in here, but the Eagle is the planner, it's the discovery, the strategy, the understanding of lineage, and coming out with a cost and time estimate for the migration. Next one, David. The Raven is, again, the transformation. How do we transform code, ETLs, move ETL to an ELT model? How do we have reliable and clean code on an open standard like Bigquery? Thanks, David. And then finally, the third one, again, is just for validation. So one of the largest and most difficult parts of any migration historically is data validation. And this takes care of most of those challenges for us. Keep going, David. So we're going to go through one or two examples now. One of the most recent ones, there was a webinar about a month ago we did with GameStop, Google GameStop and Datametica together. GameStop was on that webinar and talked about their journey. We moved them last year to Google Cloud. And this is typical of what we see in other retailers. It's not just one piece. It's an entire ecosystem that has to be moved. So in this case, they had Teradata and Vertica, they had SQL Server, they had AWS and Informatica, and that all needed to be consolidated into a unified data architecture on Google. Avoid those data silos, avoid all the ETL copying, and drive efficiency, speed, and cost in the new platform. And we were very happy, and they are too, of the result. They exceeded their cost savings and far exceeded performance and capabilities. Thank you, David. So how we helped them was we did the analysis on their systems. We came up with that unified data architecture. We drove a very fast migration for them at a low cost. We did the parallel running with our Pelican tool. And I think it was 6.5 or just around 7 months in the end that we moved the entire system, and they are now fully migrated and onto GCP. Thank you, David. I'm going to show you several others, just highlights in retail, quite a lot of retail experience. So GameStop I just talked about already, which is really an interesting one because it's very typical of what we see, a mixture of things, a little bit of cloud being consolidated, which is a growing trend, by the way. Multi-cloud sounds very interesting and attractive until you actually run it, and I have run it, and it's not as fun as it first seems when you have to reconcile and move data between clouds. So they wanted to consolidate onto GCP and move away from these legacy platforms. So we talked about that one. Thank you, David. Another one here is a combination of Teradata and Hadoop. We see this, I don't have the name on here because we don't have permission to use the retailer. It's a fairly large retailer that everyone knows. It's very common for us to see Hadoop and Teradata together, or Hadoop and Netezza together, or Hadoop and Oracle together. And I implemented years ago, almost 15 years ago, we first implemented Hadoop at Sears, for example, and that was to offload Teradata. And it's really common to see Teradata example or a warehouse like Teradata with Hadoop, where Hadoop's been used to offload some of the load from the data warehouse, stop the storage growth and the compute growth on those expensive data warehouses. Of course, it was good at the time and it worked for maybe 10 years, but now the cost of running Hadoop and the complexity of running Hadoop and the data warehouse together, synchronizing or copying data, the time and latency of doing that is becoming really obsolete. Now on BigQuery, particularly on Google on BigQuery, we can collapse Hadoop and the data warehouse together. So you'll see a lot of these examples I've used will have Hadoop and a data warehouse. And when we do that, we don't move typically Hadoop to Hadoop on cloud. We try and eliminate as much as Hadoop as possible, in many cases all of it, and put everything onto BigQuery with a very significant improvement in performance. You saw here 40% or so faster migration and cost reductions, but what we also will see is maybe 5, 10, maybe more times better performance out of BigQuery than Hadoop workloads. So performance, cost, and agility are big reasons to collapse these data silos. Thank you very much. Next one. This one was the fastest migration I think we ever did, and it was it was one of the brands we've already talked about actually. There was a Netezza system to Google Cloud, and their system was using Agility as well. So that was moved in less than 3 months to Google Cloud, and very successfully, and they've enjoyed the analytics capability. You've already heard a little bit about this company. Of being on Google Cloud. Next one. This one was one of the largest retailers in the US. Again, I can't use the name, but it's one of the really big ones. This one's quite interesting because it's really complicated. I have not even listed everything that's in here. We have Teradata, we have 2 Hadoop environments, we have some mainframe integration, we have an Azure migration to consolidate onto GCP. We have Vertex in here, we have multiple other systems. And the intention is to get out of that very complex legacy landscape with significant data latency and just operational complexity. And this is a very powerful end result for this company in terms of consolidating all of those things and cost savings over time too. The three things that drive these migrations, thanks David, 3 things that drive these migrations usually are, for us, are three areas. It's performance, limitations, including copying, data, and latency. It's cost. We are looking at big cost reductions of going to GCP. As for Teradata, for example, it's typical for us to see around 60 to 70% operating cost reduction going to BigQuery. And similar for slightly less, but similar for others. So performance, cost, and then new workload that you want to bring, streaming, unstructured data being blended with structured data, more the drive from mobile and internet to more real time. So new use cases as well. So use cases, cost and performance and data latency are really the big drivers. Here's another one, which is really Hadoop. It's very common. We see a data science platform workload being run on Hadoop, and there's now much better solutions on GCP than running data science on Hadoop. So we can move to BigQuery, BigQuery ML. We can use the BigQuery storage API to spin up ephemeral Spark clusters, R jobs, or Python and Jupyter notebooks, all on one copy of data without having silos of data anymore. It's a very powerful story. We don't have to do all the data wrangling anymore for data science. So this re-engineering of the data platform is very powerful from a data science point of view. I think maybe that was it, right? So, David.
Okay, thank you, Phil. So what we want to do now is switch gears a little bit. It's really great to hear all of us talk about these things. But what we think is important that you see some of it in action. So this next section, I'm going to be doing a walkthrough of some of the Google Analytics and AI technology in a retail context. So we'll be doing a little bit of a walkthrough. I'll do a little intro, and then we'll kind of get sort of hands-on with the technology a little bit. And what I'm going to do is I'm going to try to do follow a simple set of scenarios, the typical that certain personas in a particular retail would care about. Now, so the scenario we have here is we have a medium-sized retailer. They carry a variety of products, mainly clothing. You know, they have both e-commerce and stores as well. Obviously, a lot of that's been impacted by COVID, so they've had to, you know, change the way they do things. So they're looking to modernize, right? So what would a modern version of this retailer look like? So that's really what we're going to look into. One thing I do want to point out at the bottom is they also happen to be a Google Ads customer. So many of you, if you're in retail, probably do some level of business, whether it's with Google directly or through an agency in terms of advertising. And we have a whole set of tools and technologies around advertising. So typically, well, this is something a lot of retailers will care about in terms of how do I leverage some of that information in terms of, you know, advertising, audiences, things like that, and then start to leverage that with other information that I might have on hand. And we'll talk about that in a few minutes. Okay, so when we talk about retail in the context of data and analytics, we're really talking about a very similar problem to what Phil just talked about in many of the examples he gave, and the examples that Amy gave as well, which is I have all this data. I've got marketing data, I've got internal data, I've got third-party data, and the idea is how do I bring this data together to be able to drive insights to help me make better decisions in my business? And some of these decisions might be things like, how do I do effective analysis to understand my customer base better? How do I do the right analysis in order to make sure I'm targeting the right customers? How do I do things like activation, for example, for an email campaign? How do I know who to email? Who would be likely to buy a particular product, for example? And then also I want to be able to do things like forecast my business, understand what the demand might be for a product or a particular product, or understand what my revenue might be potential revenue could be moving forward. And then finally, I want to have new and better ways to engage with my customers, right? So how do I make the customer experience a lot better? How do I make it so that not only do customers have a good experience, but they want to continue to work with us and purchase from us? So having these different ways to pull this data together to create these different kinds of views, whether the views around the customer, views around my operations as a retailer, and then be able to effectively utilize that data in different ways. Now, there's a variety of techniques and technologies that we use on Google Cloud to allow that. I'll talk about those in a few minutes. We're going to actually hit on several of them in this. So let's take a look at a couple of those. So there's roughly 5 or 6 technologies that we'll hit on as I walk through this demo. Probably the one that you really want to understand or walk away from this presentation understanding is Bigquery. Now, not that the others aren't important, they definitely are, but Bigquery is, as Phil mentioned earlier, Bigquery is really the core of a lot of Google, a lot of the work that retailers are doing on Google Cloud. And the reason for that is, you know, unlike other data warehouses that are out there, whether they're on-prem or in the cloud, Bigquery is a fully managed service. So this isn't the kind of thing where you have to wait 3 weeks to stand up an environment, you know, or purchase a specific type of machine or anything like that. Bigquery handles all that behind the scenes. You just load, you know, you just provide your data analytics workloads and go. And as a result of that, one of the things that Bigquery brings to the table is you know, sort of this unparalleled scalability as well as performance. So from a performance standpoint, so Bigquery is really based on, as many of these technologies are based on all of Google's experience over the last 15 years in terms of what we needed to do in order to run a lot of our consumer products. So for example, technologies such as maps and photos and all these other, you know, things that everyone takes for granted, you know, there's a lot of technology behind the scenes that goes into making all that work and making that very performant. Bigquery is one of those core technologies, or is based on those core technologies, and that's what makes it very resilient and performant, more so than any other, you know, data warehouse. It's also very good at scaling out. We have customers that have tested this up to the exabyte capability, so it scales out, and it provides also that very fast performance. The other nice thing about Bigquery, it gives you a nice place to be able to pull in and organize a lot of that siloed data. Not saying you have to move all your data to Bigquery, but when you're bringing that data together to be able to perform analytics and support things such as machine learning and AI, Bigquery gives you a really good, a really strong platform to be able to do that. The other nice thing is that Bigquery does have some built-in machine learning capability of its own. And what's good about this is this allows a data engineer or someone who just knows SQL to be able to do ad hoc apply ad hoc machine learning to various data sets. And you know, the other thing I want to point out here also is we work to expose and make the data in Bigquery accessible to other parts of your business. So you don't necessarily always have to be a data person to leverage the power of Bigquery. So we have integrations into capabilities, into technologies like Google Sheets, which is, you know, really our spreadsheet type application on the cloud that can allow business analysts and others to take advantage of all the data that might be sitting inside Bigquery. We also have things like you know, natural language search capabilities that again allow those who may not necessarily be SQL experts to be able to interact with that particular data. So Bigquery is really the core here. Some of the other technologies that we're going to talk about, one's going to be called Looker. Looker is an analytics engine mainly providing visualization of analytics. It goes a lot beyond that, but visualization is one of its core capabilities. But we also allow you behind the scenes to build semantic models around your data. So as you're pulling data from Bigquery and other third-party sources, and you're building out these views of that data, these visualizations, if you will, we also give you interesting ways to be able to manipulate and manage that data behind the scenes in a very rich semantic modeling language. And it's really good for visualizing AI and ML workloads for this reason. The other nice thing is it's great for some of those real-time use cases, as is Bigquery as well. And if you're looking to embed analytics into any applications that you might be building, Looker's heavily utilized and is designed for that as well. Then we're going to talk about the Cloud AI platform. We have recently rebranded this as Vertex AI. And Vertex AI is, you may have seen the announcement like 2 or 3 weeks ago. Vertex AI is Google's core AI platform that really brings together all the tools and technologies that a machine learning specialist or a machine learning engineer or a data engineer or a data scientist might want to utilize in order to do work with AI and machine learning technology. So for example, things like Jupyter Notebooks, we have technologies like AutoML that allow you to create models with very little or no code. Also, we have an integrated ML ops model. And what's good about that is one of the big challenges with AI and machine learning is the whole idea of doing operation, of being able to effectively deploy and manage models in production and be able to handle that workflow of doing things like retraining and other types of activities. We give you a way to be able to do that that's highly scalable and very flexible. And obviously, you know, all the training and all the training of your models and everything is done on our highly scalable infrastructure that Phil referenced earlier. A couple other technologies we'll be looking at here very quickly. On Google Cloud, there's a variety of ways to do data integration. We have technologies like Data Fusion that are based on CDAP, but one of our core ones is something called Cloud Data Flow. And data flow, think of data flow as a data, it's a data processing engine that allows you to do all kinds of different data integration activities, data processing activities in a highly scalable and sort of a serverless manner. And under the covers, it leverages things like Apache Beam and open standards to do this. But it gives you a lot of different ways to be able to create your data pipelines. So for example, you can use Java, you can use Python, you can use tools that sit on top of it, like data prep that we'll see in the demo, to be able to build out your data pipelines, automate these data pipelines, whether they're real-time, whether it's a real-time data pipeline or batch, right? So again, we provide this highly scalable service to allow you to do that with Cloud Data Flow. Cloud Data Prep is a service that allows business folks to actually build out and design out some of these data pipelines, and that leverages data flow behind the scenes in order to do the actual execution of it. And we'll talk a little bit about that during the demo. Dialogflow, you heard Amy earlier talk about CCAI. That's our contact center AI solution. Dialogflow is the core of that solution. It's our conversational AI service. So this is really a way for you to build out omni-channel conversation flows that your customers can interact with, whether that's through chatbot, SMS. We integrate very tightly with a lot of the IVR providers out there, like Cisco and Genesys and Five9 and all those. And many of those are what we call one-click integration. So it makes it very easy to enable those integrations. And obviously, this has a full API tied to it. So what that allows you to do is it allows you to incorporate these interactions with other applications that might be part of your business. For example, a back-end system where you may have to pull customer information or something like that. So we give you all that capability and flexibility. And then finally, the one thing we'll touch on a little bit is recommendation AI. This is something that Amy mentioned earlier. So every website out there, or most of them, most retail sites do have some form of recommendation piece to it. The challenge a lot of retailers have with that is they typically have to build and maintain a lot of that themselves. There's a lot of there's a lot of libraries out there you can use for it. We have customers that have built their own from scratch. There's various ways people have done it. What recommendation AI is, it takes a lot of that away from you, and it makes recommendation a fully managed service. So really, you tell recommendation AI what your goal is. You provide it with the data to train, and then you link that model that's created to your e-commerce site, and that website will then utilize it for recommendations. And we'll see a simple example of that. And again, all this is done with privacy in mind. Everything done with recommendation AI. It's your model, it's your data, and it's your models. That data is not provided to anyone else. All of it's private to you. So it's nothing we're doing with the outside world or anything like that. So those are some of the key services that we'll be working with as I walk through this here. And then real quick, before we start, I just want to talk a little bit about the personas that you will want to keep in mind as I'm going through this. We'll talk a little bit about some of the things that market analysts will care about. For example, how effective are the ad campaigns? Who should they be targeting ads at? Things like that. We'll also look at operations, right? So, are things, what's the status of our shipping? Are we shipping things on time? What's our performance look like there? And obviously, and as I mentioned earlier, being able to optimize inventory, right? So how do I forecast demand moving forward? And then we might want to think about what a store associate would care about, because not everything is done online, right? So what is a store associate? So when a store associate interacts with a customer, they might want to know something about that customer, right? So what is it that what kind of information can we give them? And obviously they care about things like health of their store and their operations of their store and so on. So some of the other personas to keep in mind here, they're what I call enabling personas in the data world. And these will be folks like data engineers and data scientists. So a data engineer is worried about, how do I take all this data and put it in and make it available and accessible by others in the business. And then finally, a data scientist wants to be able to build out models, build out machine learning models to apply to particular business problems. And we'll talk a little bit about that as well. Okay. And then finally, I'm not going to go through this exact use case that's here, but this is just an example. We'll talk a little bit about the end customer, right? So the end customer, what is it how can we improve their experience in terms of interacting with us using technologies like Dialogflow in this case. And with that, I'm going to go into a little bit of a demo now. And let me just share another screen here. And I think it's this one here. Here we go. Okay, can everyone see my screen? Phil, can you see my screen?
Can now, yep.
Is it like a dashboard?
Yes, David.
Okay, perfect. Okay. So we're going to start here. So what I'm showing right now, this is a technology, and it's not directly part of Google Cloud. It's actually part of more on our Google advertising side, but it's sort of our starting point here. And this is called Google Analytics. This is used by marketing folks and usually marketing folks by companies who are usually using Google Ads as well to better understand their online audience, right? To understand the kinds of behaviors that people are doing online, where they're from, and what kinds of things they're doing. Are they looking at things? Are they filling their shopping carts? Are they buying things? And so on. So a request that we get a lot from our customers is they want to be able to take this data that GA, in this case, the Google Analytics provides, and make that data available, and take that data and combine it with other kinds of data. Okay, and they want to be able to combine it with data that they might have in-house, right? So data about their, direct data about their customers, loyalty, combine it with maybe loyalty programs and other kinds of things that data that Google Analytics doesn't necessarily have access to. So Google Analytics can only pull data from the ad related events that are happening. So the good news is Google Analytics has an integration with Bigquery that allows a retailer to be able to pull in this information into Bigquery, and then from there use that as a platform to be able to pull that and some of the data prep tools that we'll talk about in a minute to pull some of that information together. So we're going to go there next. So here I have this is Bigquery. This is the user interface for Bigquery. I can do all kinds of things in here, like I can actually create tables in here if I want to, but most organizations will do that through the API or through a SQL call. I can create SQL jobs in here. I can do all kinds of things. We're not going to go through all the functionality here, but I just wanted to pop this up. And again, this is a fully managed service, right? So there's nothing to set up here. You just log in, load your workload, and go. And then we only bill for the query time that you use, right? So you don't pay for an instance. You pay for the query time that you use. So if you use 3 seconds of query, you pay for 3 seconds of query, plus whatever that related storage is, right? So you're not paying for like you might for other with other cloud data warehouses or on-prem data warehouses where you're sort of paying a fixed cost for an instance. This is really more based on consumption. Okay. So anyway, I mentioned earlier we want to bring that data over. So right here, I have a table in here, and I'll just preview it. This is our data that we brought in from Google Analytics, and there's a lot of detail there. I'm not going to get into it, but really this is just who clicked on what, or I'm sorry, what clicks happened, where they were located, what ad was it in response to, and then there's actually a whole set of other data behind this, but this is the main data set that I brought in. Okay, and you can see in the details here that it's about 1.9 million rows. And the reason I'm pointing that out is because it's important for later. Now, I want to be able to combine, I want to be able to achieve, as a marketing person, I want to understand how effective my ads are being at promoting sales in my loyal customers. Okay, so I know who my loyal customers are. I have information on them. I know who they are. I know their email addresses, all that. And many of those people, when they use our website, they log in with their email. So I know who they are, right? On the other hand, there is a lot of other people who log into the web, who come to the website. I don't know who they are.
they're not loyal customers. But I really care about what ads are really causing our existing customers to buy more, right? So I need to be able to take this data and combine it with known data I have about my customers, right? And right now, as an organization, that data is sitting in MySQL databases. Those could be cloud databases on GCP. They could be on-prem. It doesn't matter. But that data is sitting in a database somewhere. So in order to combine this data, I can use I could set up data pipelines. And these data pipelines, I have 2 data pipelines here. And one of these data pipelines takes all the transaction data I have in MySQL and my customer data that I have in MySQL and combines that with the event data that I just showed you. Okay, so there's, you know, and this is not necessarily going to take all 1.9 million of those records and convert and link them all together. The reason for it is there are many customers we can't identify because we do not identify customers unless they've specifically given us information. So the only customers we have information on are customers that are known customers who have logged in with their email, with their username and password or whatever. So we only wind up with about 400,000 records at the end of this. So that's the first part of the flow, right? So we've combined our known customer data with the transactions, in other words, purchases that people have made. And by the way, this could be purchases made in the store, and it could be purchases made online. That's what's really nice about this, is I can now look at, okay, which of my customers that are responding to ads are actually buying in store, right? So there's a lot of different, or they're picking up in store. So there's a lot of, there's a lot I can do here. So that's the first flow. The second flow that I have is I want to be able to understand which ads were driving these sales, right? So there's a number of other pieces of data from Google Analytics and the broader ads platform that I've pulled in here. So I've pulled in the ad events that we talked about earlier, what are called keywords, ad groups, and campaigns. This is all advertising, Google advertising terminology and digital marketing terminology for these particular events. So you can see in this flow here that I have that at the end, whoops, let me close that. I wind up with, with sort of a view of, or an understanding of what ads have directly driven those sales. So if I go back to Bigquery, and what it did is it put that data inside Bigquery. So if I go back to Bigquery, here's the final data set that I have. And notice it's only 243,000 rows. And that's because not every customer was identifiable, because again, we can't identify customers unless they specifically identify themselves to us, right? So it's, again, so we took that 1.9, we only have 243,000 instances of where one of our known customers actually bought something online. So now that I have this data, as a marketing person, how do I consume it, right? How do I analyze it? So what we can do with that is we can go to a dashboard here. This is Looker. I'm not going to get into the details of how this dashboard's built or anything like that, but this is a dashboard I built based on this data. And what's probably the chart that's probably most important here is this one here. This shows me, based on the amount of money I spent on a particular ad campaign. These are all different ad campaigns at the bottom. The particular amount of money I spent, how much revenue was I able to drive for that. Notice in some campaigns we wound up spending a little bit more than what we got, and then other ones we did quite well, right? So this tells me as a marketing person, maybe in the future I want to put more money and more investment in these kinds of ads for, if we're trying to attract our loyal customers versus whatever these ads are over here, right? So I think these were display promos. So there's again, just a way to look at the data. There's all kinds of ways you can view this data. You can look at it by ad type, whether it's search, display, video. Notice most of it, purchase by channel type. So whether it's in-store, online, or store pickup, most of these, notice are actually in-store. And then type by brand, right? Whether it's video, or actually, I'm sorry, the brands, which brands are being driven by what kind of ad, right? So for example, Video ads seem to be really good for Armani and ASICs, whereas the others are a little bit more mixed. And then we can do other analytics around other analytics here around things like demographics and so on. So from a marketing person standpoint, this helps me better target my ad data. So as a marketing person, another thing that I care about is what other ads could I potentially target to my customer base. And so the idea here is I want to understand, and I also want to understand what, based on past performance, what is the expectation for customers to potentially buy certain things in the future. And that's what we call propensity. And propensity is sort of a classical machine learning AI problem that a lot of retailers care about, not just traditional retailers, but also especially things like cell phone providers and others care about propensity, right, for different reasons. But here we care more about prediction on whether or not which customers are most likely to purchase. And if they're more likely to purchase, we can then go target those specific customers with ads. Again, we're talking about known customers. Okay, we can't do this with random people out there. These are known customers. So in order to do that, I need to get the help of a data scientist or a machine learning specialist, right? So I want to build out a model to help me do this. And as we talked about earlier, that's really where Vertex, Google Vertex comes in. There we go. So where Google Vertex comes into play. So as I mentioned earlier, Vertex is sort of our unified AI platform, right? So all these different things, that types of capabilities that data scientists and data engineers and others who work with AI and ML care about are here. We do pipelines, building out model, we use notebooks and other kinds of things. And a lot of these are fully managed services. So for example, we have things called auto ML models, and you'll see one of those in a minute. The nice thing about auto ML models, you don't need to write code to do it, right? So it makes building these kinds of things very fast. So we're going to show an example of that right now. So so what I want to do is I want to build a propensity model based on a specific data set. And what I can do here is I already have this all built out, but I'm just going to go ahead and show you how it works. So the first thing I do when I want to use Vertex to build out a model for me, I want to, let me just type the name. Oops. First, I need to tell it what data I want to use to train a model. So the first step in doing this is to train a model, right? So you need to provide a data set for Vertex to use. And there's different kinds of training we can do here. We can do all kinds of stuff with images, tabular, which is what we'll be working with today, text analytics, and then video as well. There's all kinds of cool stuff we can do with video here. But for right now, we're going to deal with tabular. And there's two types. There's regression classification. Those are sort of your classical machine learning problems. And then we have forecasting, which we'll talk about a little bit later. So what I can do with here is select regression classifications. So propensity tends to be a regression, tends to utilize regression. So I can go ahead and provide, I can provide it a particular data set that I want to target. And let me just copy and paste the data set here. The link, I should say, to the data set, so I know which one it is. Okay, so that's my data set. Again, that's a data set sitting in Bigquery. This data could be sitting on your computer. It could be sitting in cloud storage or Bigquery. So I have a data set in Bigquery. And what it does is it gives me a little bit of a breakdown of the data. Notice the thing I want to predict is will purchase in the future. That's the thing I care about, right? And then from there, I can use this data to train a new model. Okay, and you can create a custom model. Certainly a data scientist might want to do that if you have a very specific thing that you want to address, or you need to do some additional processing on the data, or you've built a custom model yourself. But here I can use AutoML. What's nice about AutoML is I just select classification or regression. In this case, it's a regression problem. Click continue and give it the target column, which in this case is will purchase. That's the thing I want to predict. And it's going to ask me what columns I care about in terms of helping with the prediction. I'm just going to go ahead and click continue. There's a couple other fields I can fill out in terms of options, in terms of what my optimization objective is. Depending on what kind of model I'm building, I'm just going to leave all those the same. I can, and then I can talk about what budget I want in terms of number of hours. Now, I'm not going to run this model right now. So what'll happen is when I click start training, it would start training the model. Okay, it would actually be building a model. I didn't have to write any code to do this. So I'm going to go ahead and cancel this because I've already built the model. Okay, and because it takes a little time to build the model, and it's more time than we have here. So if I go here and look under models, we see that there's two models here. There's demand forecast and propensity model, purchase prediction. That's the model that was created. And it talks about things like feature importance and other metrics that are important to the model. Now, here's what's nice about Vertex. Vertex allows me to take this model and do a couple of things with it. It can allow me to actually make this model available as an endpoint so my application can call it. Okay, so I can create an endpoint, which is just a URL that tells an application to go out and that an application can actually access. Okay, and then from there, that application can then can call predictions based on data that's coming into that application. So you can do that. The other thing that you can do here is you can also export this model and use it on at the edge as well. So we have ways you can deploy model, for example, on edge devices and things like that. So if you have a device that doesn't have access to the cloud, or you need to run it on special hardware on-prem, you can take this model and then deploy it wherever you need to, right? So there's a couple different ways that you can work with this model. So that's the model. So what's the ultimate result of that? So now that I've done that, I can now use this data. My marketing specialist can then go ahead and use this data to get a view of, what's some of the likelihood of some of our, what are some of the recommended things that I can do in terms of positioning to audiences. What's the propensity to purchase if I do a certain kind of ad? If I do a social ad, for example, or target someone to actually do a search of our website, or a referral, or other paid search, other kinds of things. What's the propensity if I invest in a certain set of campaigns to a certain set of people? What's the likelihood they're going to buy? And you can see there's a lot of them. These that are in the 90s. I think this one the view here only goes down to 90 or 92. Obviously, it all goes down all the way down to 0, depending on the data. We had a pretty large data set. And it gives me this view gives me a lot of other information in terms of expected revenue, expected profit, and other kinds of things. And again, all that from that propensity model that I built. So I was able to have a data scientist or a data engineer go and quickly build out a model and then make that model available to be viewed here by a marketing specialist. Okay. So moving on, let's shift gears a little bit here and talk a little bit about operations. And so one of the things, and again, I'm just going to show this one as a dashboard here, but one of the things that that from a logistics standpoint that operations folks care about, especially today with everything being shipped all over the place, not just shipping to people's homes, but shipping to store, having people pick it up, is this whole idea of being able to get a handle on all that. The volume is huge right now. And the idea is that you want to have an understanding especially from a customer satisfaction standpoint, are you behind on shipments? Where are the areas that you're having problems in your shipping process? So being able to leverage data using a lot of the techniques I showed you earlier in terms of bringing data together, and then potentially running some models against it as well. Being able to get a full view of the health of shipping. Where things are challenging, where there's a lot of shipping going on, and so on. So there's a lot of things that we can do here for this from a shipping standpoint. So the other piece of operations I want to talk about is demand forecasting. Now, this sort of bleeds into store as well, store operations as well. But earlier, Amy talked about this whole idea of doing demand forecasting. So again, as part of our Vertex AI platform, we have, and you saw this earlier. In fact, I'll bring it up right now. Oops, wrong one. I go back to Vertex. There we go. Whoops, let me turn that off. There we go. So you saw earlier, I have a demand forecast model. So in the same way that I created my model for propensity, I can do the exact same thing for forecasting. It'll with a few subtle differences, right? So I go ahead and I create it. I go ahead and I do tabular again. I do forecasting this time. I click on create, and let me just grab my my data set link here. Copy and paste it. And again, I go through the same kind of process that I did before. There's a little bit of nuance to demand forecast. I'll get to that in a minute. And if I click on training model, so something, and I click on AutoML again, there's a little bit of a difference here. So when you do demand forecasting, what we require some different things, right? And the reason for that is the algorithms under the covers are doing is solving a completely different problem than something like propensity, right? We're trying to predict on something in the future. So what we're actually trying to predict in this case, for example, might want to predict quantity of product sold, or we might want to predict sales. So let's pick quantity, for example. The series identifier column is important because that tells us how many different series do we want. So typically what we would do in retail is we might do this on store or product, right? We want to understand on a per product basis what the demand might be, or on a per store basis what it might be. So we could pick store, for example. Time series column, this is important because you need to track time. Granularity, do you want daily, weekly, hourly? You know, let's pick daily. Forecast horizon, this is important. How much time in the future do you want to forecast? So let's say we want to forecast 7 days moving forward. And then there's some advanced options here, and this is important. So whenever you're training a model, I meant to show this earlier, that you need to take your training data, that's the data that's sitting in Bigquery right now, and you need to tell it how much of that data is used for training, how much of it's going to be used for validation and testing, right? That's a classic machine learning type of decision that you need to make. Typically 80-10-10 is very common. Some do it a little bit different. It depends on the model you're building. And then of course we do continue, and we go off and we pick which things we care about, and we go off and we build the model, right? So since we're not going to run this model again, this will take time. So we already have one that's built. This is our demand forecast model that I built earlier a couple weeks ago, and all the different statistics tied to it. You can do batch predictions if you want, and obviously there's different properties associated with the model, etc. So you can get all that particular information. Now, from an operations standpoint, how do I use this particular capability? How do I use this particular model? So one way I can do that is with, again, providing views that my business can then utilize. Again, we're going back to dashboards. And the reason we're going back to dashboards is the personas, people like operations people and marketing people and store associates, this is what they would be looking at, right? So you can see the demand forecast here. What the one on the top here is showing is it's showing, you know, here's our goal of sales. We did this one on revenue. Here's our goal of sales as the green line. This is our projected sales in the gray. And what this means is that we're not projecting to meet our sales. So this tells me that maybe we want to do some promotions to potentially change that equation moving forward. So maybe, right now we want to take some action in order to be able to change that trajectory moving forward. Another way to look at this data is to look at it by brand as well. That's just another way. You can look at it by a lot of different dimensions, but here's a view by brand, right? So we have 3 brands, Neff, Hanes, and Lee. And what we're showing here is what would be the potential uplift if we did a promotion. So the target is in orange, the forecasted is in green, the target is in orange. So again, we're not going to make our target, but if we did a promotion, what would the expected lift be? And promotions are something that we can actually bake into our demand forecasting model. We can actually add different data points to when we build our model to account for things like promotions, holiday sales, whatever it is. And so this is what one of the things that we can do. So demand forecasting, again, is a really key thing that's part of Vertex, particularly helpful for our retail customers, but really is applicable to any industry, to some of the points that Amy made earlier. So, so that's our demand forecast. So one of the other things I do want to point out as well is even at a store level, if I look at a store associate, for example, if I'm a store manager, one of the other things that I can do, again, using all the techniques that I showed you earlier in terms of bringing the data together, I can get interesting views about the operations of a specific store. And this can be very useful for a store associate to be able to, so every store associate could have a common view of what their store looks like, right? So whether it's sales, transactions, loyalty, what's the weather trend going to be, and how might that affect, and what's the trend versus peer stores. For some reason, this one isn't coming up. I don't think the data is here, but what's my trend versus, let's say, my peer store in San Francisco or some other city, right? So as a store associate, I can utilize this same platform and the same views. And by the way, this could be on an iPad or a tablet or an Android tablet or a phone or anything. It doesn't have to be on the web. All the Looker views you've been seeing, I'm just showing them on the web as it's easier to demo it that way. But these could all be linked to an application that is part of a tablet application, whether that's Android, iOS, whatever. So it's just something to think about from that perspective. So let's talk about the customer. Let's talk about the end customer, the retail customer. So a couple things that they care about. They want a good experience, and I'm going to show two different things here. One is around the experience on the website. Now think of this. This is our website here, and of our store. This is actually our store website. It's pretty simple. I'm just going to sign in. And notice that when let's say I pick these socks here, it's recently viewed. When I go to pick these socks, it also says frequently bought together. This is stuff you see on a lot of most retail websites, right? The difference here is that building this out was very easy and straightforward. Being able to incorporate this into my website was very easy and straightforward because I used a serverless. I'm using a managed service to do this as opposed to writing code myself to do it, right? And again, that creates a lot of maintenance headaches. And actually, the performance, what a lot of our retail customers tell us, is the performance is actually a lot better than something they might have built themselves or used even from another party. So again, these kinds of things are frequently bought together. Other customers also bought. All these kinds of things are part of creating a good customer experience, and being able to enhance what you already have in recommendation, or being able to introduce a better recommendation alternative is what we can do with what we call recommendation AI. And so what I want to do is let me show you how that's done. So this is our recommendation AI platform, and if I want to create a model that my website uses, I can click on Create Model, very similar to Vertex, by the way. And it asks what kind of model type. Chances are you're going to use more than one of these, right? But others you may like, frequently bought together, recommended for you. These are pretty standard kinds of things. You can set your business objectives. And then what you do is you provide data. You provide two types of data. You provide your catalog of your products, right? In terms of price, in stock, what category they are, etc. And you provide past event information. Now I'm going to pick a custom range here because The data I have in here is kind of old, so let me just go back and just do back to 2020, and I'll just do till today. So this is the data that I import, and this data could be coming from, it's really coming from past transactions on the website and past interactions on the website. So I have this catalog, this backlog of data that I can use to feed into the model, and I can do this continuously. I can have this model get better and better and better over time by continuously feeding this data in. But this is the event data that I provided. This is the catalog data that I provide, and that's what I use. That when I go to create a model, I can then go ahead and utilize this data. So, for example, frequently bought together is the model I created. Notice I have there's some prerequisites. You have to have at least 1,000 purchases in the last 365 days I have, and at least 90 days worth of data. So you don't need tons and tons of data to make this work, but you need a good amount of data. But you don't need like 6 years worth. You need like 90 days minimum, right? So it's not too hard of a lift to get that data. And of course your catalog. So now that I've created that model, all I have to do is point my website to that model to utilize it to actually do what I was showing earlier, which is provide these views here, frequently bought together, and etc. This particular website has, I think, all three model types implemented in here. So again, that's one way of enhancing your customer experience. Give them a better recommendation capability and do it very quickly, as opposed to having to write a lot of code yourself. Right, so that's one aspect. So that brings us to our final topic, which is, let's talk about engaging with the customer, engaging with your customer. I want to show a simple example of that as well. So I mentioned earlier we have something called dialog flow. Dialog flow is Google Cloud's conversational AI engine. And it's based on all of our experience and lessons learned in doing natural language and other types of AI technologies throughout the years. So a lot of what has been done with Google Assistant and other kinds of natural language applications, all of that experience has been brought in to conversational AI. And then the advantage here is that you don't need to necessarily train it with a million phrases to actually build a model that works well, right? Other solutions out there might require you to build out a lot of, or to have like a whole bunch of information. We can do that with less training or with less information. We can train with less information because we have those algorithms behind the scenes that, and all those lessons learned that we can leverage. The other nice thing about this is the model continuously trains itself. So as you add things or add phrases and other things, it continuously trains. You don't have to send things off to be trained by the vendor or anything like that. It's all done for you automatically. The other key thing to think about here is everything I'm doing here to build out a conversation flow, and I'm going to pull up a simpler one. Let me pull up a simpler one in here. Whoops, not that one. I want to pull up, let me pull up a different one here. Here we go. Retail demo. And I have this in-store virtual assistant, okay? And this is a simple one, right? So basically it's going to start, a customer's going to come into a chatbot, let's say, they're going to search for a product, they're going to decide to search by photo, search by catalog, and we'll provide them a recommendation. And if not, we can hand that off to a store associate or to a call center person. It really doesn't matter. And as I mentioned earlier, this is all omni-channel by default. So everything I'm building here applies to whether it's a voice interaction, an SMS interaction. I don't need to have multiple types of technologies to build out and manage for that. I can do all that from here, from one flow, right? And it just automatically applies. And then, of course, I do things like agent handover and things like that because we have those integrations with Genesis and all the other telecom providers that are out there. So let me show this. Let me show an example of this in action, a very simple one. And I'm just going to do a simple chat bot. So I built out this chat or this model here, and I'm going to need to share a different app. So let me do that real quick. And we only have a couple minutes left, so I'll be very quick. Let me just share that. And I'm going to share a different window here. Okay. All right, Phil, can you see that? Telegram?
It's coming. Not yet. Now I can, yeah.
Oh, perfect. Okay. So this is a simple bot, a simple chat bot that I put together using that model. We have an integration to Telegram, and I just wanted to keep it real simple so that we can just show you how some of this works. So I used our Telegram interface. We actually have an out-of-the-box one too that you can use. You can integrate this with Facebook or whatever messenger you happen to have, as well as all the telecom providers I mentioned earlier. So it's telling me, welcome, how can I help you? And I want to say, I want to buy sunglasses. Oops. I want to buy sunglasses. So what's going to happen now is it's going to ask me a question. It's going to say, do you have an example of the style of sunglasses, or do you want to browse? Right? Browsing will just take me to the catalog on the website, which I don't really want to do because it's not as exciting. But I want to say that I have an example. Okay. And what that will do, that will allow me to upload a photo of something like what I want. So this goes back to that retail search that Amy was talking about back at the beginning, which was being able to have a retail a search capability specific for your product catalog. That's similar to Google search, but it's specific and private to you, right? So being able to do that by just providing an example of something without knowing what the product is, I can do it. So I'm going to say I have an example. I kept this one pretty simple. So what I did here, I just went ahead and automated the picture here just to make it quick. But this is the photo I uploaded. This is, I don't know if anyone recognizes this. This is Leonardo DiCaprio, I think, wearing these particular sunglasses. Okay, I think it's from the movie, Wolf of Wall Street. So there's these sunglasses here. And what it's saying is it's going to find the best match. Here's a great option. Would you like to purchase this item, or do you need more information? So here's what it's recommending. Based on what it saw here, it pulled this out of my catalog and said, this is the one we recommend. And would you like to purchase it, or do you have more questions? I'm going to click on I have questions. Okay, and it says, sure, how can I help you? Do you have a matching hat? Now here's an example. It's saying, sorry, I don't know that. Do you want me to connect you with a local store associate? Right. So here, what we do is it can actually do two things. It could forward me to a call center, which I don't have in this demo because I don't have a call center. But it could forward me to a call center, or it could actually forward me to a chat with a store associate. Right. So it can do either of those things. Right. So we can do all those handoffs very, very seamlessly. So again, you can incorporate this and make this as sophisticated or as simple as you want to into your customer experience. Place this in your mobile app. Place it in on your website. Okay, and so kind of wrapping this up here, there's just a kind of a walkthrough of sort of the different personas and some of the experiences that Google Cloud can create from a retail perspective for those personas, leveraging a set of technologies that require less code, and many of which or actually all of which are managed services that allow you to get up and running quickly. And apply these technologies quickly so that you can have more, you can start having more of an impact to your business faster, right? So that's kind of the focus here. And with that, I think it's time for us to wrap up. I think we're at time. Again, if anyone has any questions on anything we discussed on this session, please feel free to reach out. To myself or Phil or Datametica directly. We can definitely help out. If you're working with someone from Google currently and you have some questions, feel free to reach out to whoever your Google representative is. And with that, I personally like to thank everyone for attending. And Phil and Amy, thank you for your presentations. And I think with that, we're done.
Very good. Thank you, David. Thanks to everyone. Questions are very welcome. You should be able to find our contact information, and we'd love to hear from you.